will be able to determine an appropriate trigonometric ratio for a given right triangle. I will be able to solve for missing sides of a right triangle using trigonometric ratios. So in the previous lessons and the previous videos, we talked about just setting up ratios for right triangles, right? We use that thing SOHCAHTOA. Here we're actually going to be solving for missing sides of right triangles using those trigonometric ratios. So just real quick, determine an appropriate trigonometric ratio, right? So how can we determine which trigonometric ratio to use based on the information given? Which piece of information do you think is most useful in helping us determine the ratio? So at this point, I'd like you to maybe stop the video and just kind of think about what you think is most important. Okay, so maybe you stopped the video, maybe you didn't, but let's take a look. The most important thing here is the reference angle, okay? So the angle that we're referring to is going to be the most important. The reason for that is these are trigonometric ratios, and as we know, we use that SOHCAHTOA, right? Sine, cosine, and tangent to solve for these. Okay, so the most important thing here is our reference angle, and that's going to allow us to figure out, are we using sine, are we using cosine, or are we using the tangent function? And I'm going to show you in the calculator how you can actually use those functions. So in this case, right, we know that we have a hypotenuse, right, because obviously this is opposite the right angle. Okay, then we know if we look at the reference angle, right, this x that we're looking for is actually adjacent to our reference angle, right? It's not opposite. Opposite would be over here. This x is adjacent to our reference angle. So we are going to end up using the part of SOHCAHTOA, which is cosine, right? Cosine being equal to adjacent over hypotenuse. But what is it the cosine of? Well, it's the cosine of that actual angle. So we have to do cosine of 30 degrees is equal to adjacent. Well, adjacent we don't know. It's x over the hypotenuse, which is 24. So now this might look a little bit confusing because we've never dealt with these types of functions before. But in reality, it's no different than solving a regular problem. So what you want to do here is when you're confronted with a fraction on one side or a ratio on one side of an equal sign and something on the other side, you want to cross multiply. So we know if I divide this by 1, it doesn't change it at all. So I'm just going to put that 1 there so we can see that I'm cross multiplying. When I cross multiply, I get x times 1, right? X times 1 is just x, and I get it to be equal to 24, right? 24 times the cosine of 30 degrees. Now, I don't know what the cosine of 30 degrees is. I don't. So what I'm going to do here is I'm actually going to use my calculator. And I know when I do 24 times the cosine of 30 degrees, that will be what my x is equal to. So if you have Delta Math, if you don't, you can find an online calculator. But if you have Delta Math, they give you a calculator here. So we're going to hit functions. We're going to make sure we're in degree mode, right? And recall, we want to do 24 times cosine of 30. So I'm going to hit actually this shift, this 1, 2, 3, and I'm going to do 24 times my function, the cosine, and I'm in degree mode, of 30 degrees. And that's going to give me my answer. And it's 20.7846. And in fact, I'm going to round this to 21. So x here is equal to 21. And that's all you got to do. You're setting up your ratio and then you're cross multiplying. That's it. Set up your ratio and cross multiply. So let's just set up a couple more ratios and you guys can do the cross multiplying yourself. Here we're looking at our reference angle is 57. This is opposite, and this is opposite the hypotenuse, so it's our opposite the right angle, so it's our hypotenuse. So we've got an opposite and a hypotenuse. We're going to use sine because that's so. So I've got sine of 57, right? Sine of 57 degrees is equal to opposite, which is x, over 8 feet. Okay, I'm going to put this guy over 1. I'm going to cross multiply again. And you'll head into your calculator and do 8 times this sine of 57. 57 is equal to x. And you'll get your answer for x. And this one down here, we can see that we've got our opposite and we've got our adjacent. There's nothing that's opposite the right angle, so we don't have this hypotenuse. So I know I'm going to be using the TOA part of SOHCAHTOA for my tangent. So I get tangent of 40 degrees is going to be equal to OA, right? Opposite, which is my x, over 12. Okay? And again, you will cross multiply. All right? And you'll just solve for x this way. Okay? And that's really it. And that's being able to solve for missing sides of right triangles using trigonometric ratios. You're just putting your ratios in, and now you're solving for x.